electronic products are created today and the ones that give added value are ones where co-design is really important?
That is already critical to the UK, but it's only 20% of the total picture.
Well, as Steve said, what the UK is good at is some of the niche, higher value technologies where there's real innovation and value add that produce from the UK supply chain. So in terms of the UK capability, you can broadly describe that as three main areas. One is the sort of power electronics, second is sensing and communications, and the third is this more traditional silicon analog electronics, which has also been something that the UK has done for quite a long time as well. So from fab capability right through up to system level, you have a UK supply chain that can feed into those high value markets into automotive. So it's not the race to the bottom where you're looking at some of the the memory or controller technologies which cost billions, but you've actually got a UK capability that can provide the sort of integrated system components and all the levels underneath that into the automotive market in areas where it's very stable markets as well. Some of the UK capabilities have been running for 20, 30 years. They'll continue to do so and innovate, and they're still there because they're innovating, they've got low cost, but high value add as well. So lots of opportunity.
Yeah, I agree with most of that. I think the UK semiconductor capability has been for over 30, 40 years here, has been very strong, although lesser today than it was certainly 20 years ago. In the UK, a lot of international companies came to the UK, and they came to the UK for several reasons. One was the actual skill set, design capability, the infrastructure we had, and also facilities. And some of the facilities was like abundance of clean water, which you need in the manufacture of semiconductors. So we had a dominance in Europe, and certainly mainly in Scotland, and some to other parts of the UK, like Midlands and also in Wales. And so over the years, what has actually done is the price break of those chips have actually gone offshore, and they've gone to lower cost levels. They've gone to places like China, and they've gone to Asia. That was primarily it was financial driven or cost driven, but today with the costs in China where prices have gone up, and what they've decided to do is they've had to go into automation. And so automation has been the big driver towards the leading edge of the semiconductor side. Where you look at the design capability in the UK in supply chain, as I say, there is still that excellence there, although to a lesser degree. And if you find where the semiconductor has gone in the past, it has been driven mainly by political or financial funding. Despite that, we still have got a very strong overall infrastructure in the UK. And if you actually take it from the basic wafer, which I've got some on the table here, all the way through to the design and then to the finished product. Unfortunately, a lot of the product we've got today is actually physically going offshore. And what we've got to do is to turn around and say, we need this connectivity within the UK, within the supply chain. We've got the requirements, especially in the power side. And although we talk about automation and we talk about power, whether it's for automobiles, for wind, for hydro, a lot of the basic components that go into those circuitry and those chipsets are actually manufactured in the UK. But unfortunately, a lot of it actually goes offshore. And I think what we've got to do, and certainly with the NMI and Techworks, what we're trying to do is to harmonize and bring these bodies together so that we actually can knit the supply chain together. And I think that's our challenge today in getting that message across the government.
Yeah, absolutely. I think the electronic products that are created today and the ones that give added value are ones where co-design is really important.
Yeah.
So it's no longer a case of just one part of the supply chain just handing off to the next and not knowing what each other's
Absolutely,
doing.
yeah.
So, for example, the Escape project that Steve talked about with McLaren, so that's effectively an automotive tier one talking to a semiconductor fab, and the interaction between that to actually optimize the electronic system that's produced. And it's the same in the sort of three main areas. So power electronics and future wide bandgap power electronics, gallium nitride, silicon carbide, that's essential because you have to optimize the system to get the chip to work to the best way it can. Similarly in photonics, so you look at photonic integrated circuits, and you've got Sivers in Scotland that can actually produce that volume core chips for that. Again, the interaction between that and the next generation photonic integrated circuits that should go into automotive sort of CAV systems. The interaction between the tier one and the fab's important. And similarly in communications, so if you've got a built-in radar into a car, at the heart of that is gallium nitride phased array RF devices, which can be manufactured and designed and built in the UK. And in each case, you need an integrated supply chain through chip, through packaging, up the subsystem that actually work with each other to actually modify it. So then there's the opportunity for a UK joined up supply chain. And then each of those elements within the supply chain, once that's established and successful, can also work on a global basis as well. So there's a lot of opportunity.
And do you think there is actually sectors of that whole supply chain that we are weak in, or where our strengths are?
Yeah, so there are always gaps, in some of that. So there's opportunities. Most of the areas there's UK. There's some elements, say in power electronics. So for example, capacitors and passive devices are quite important within the system. There's not much but there's a couple of small companies in the UK that could potentially be growing. So it's also important to sort of understand where the gaps are. In terms of semiconductor manufacturing, there's actually a lot of capability. There's at least 15 commercial fabs spread right across the UK in semiconductors with the capability to develop and grow in those areas for automotive and support the automotive supply chain. So it's still there. It might not be there. It needs the investment, it needs the growth to support it. But with the driving pressures in both electrification and autonomy, it's actually a very good opportunity for the UK to actually harness that, and they've got the capability now to be able to exploit it.
I think one of the things that talking to some of the members from the NMI is that if you look at the investment into the semiconductor sector in the UK and the supply chain, it's all, what could I say, self-driven, privately driven.
Absolutely.
And yet if you actually look at the inward investment by external companies who recognise the value in the UK, you've got several companies investing billions in the UK over the next 3 years. And if they're looking at 5G technology, they're looking at firewalls, they're looking at software design, they recognise the capabilities here. And I think what we've got to do is we've got to capitalise on that. We've got to bring that together and sort of highlight it towards government that we've got the Cordino there, and we shouldn't be giving it away.
Absolutely. So if you look at, say, power electronics, if you define a tier one as somebody that can design or manufacture a converter, an inverter or a charger, there's over 70 companies in the UK and growing that have actually got that capability.
Yeah.
But you've got the underpinning supply chain in terms of design, packaging, integration, semiconductors, that they can work with those companies to sort of grow. And they're coming here because of that capability.
Yeah, absolutely.
And the high level of, very joined up approach in the UK, highly collaborative.
I personally think there's a mindset in government is that they look what's happening, the investment that's going on in the Taiwan, for instance. You've got one private investor putting in 400 billion over the next 3 years. You've got President Biden putting 250 billion to it. And I think the government has got to make a conscious decision, is this a part they want to play in the sector? And I think they must. I think any modern day nation, if they're not a leader in technology, they haven't got the security, they haven't got the control, they haven't got traceability, they haven't got communication skills, they haven't got the automobiles, they haven't got the aircraft. There's a whole interconnectivity there. And so the government have got to make a conscious decision, do they want to be in it or not? Not in segments, but bring it all together. And so from that point of view, I think my message to government is, look, we have got the capability here, we've had it here for the last 30 years, recognise it, and it's not a case of investing into startup companies costing 10, 20, 30 billion. What is this supporting our semiconductor industry? And so if you look at anything, including the electrification of cars and everything, right, there's 4 sectors there, right, which are driving that. There's one is first of all, is regulations, and that's regarding safety, the exhaust, and the rest of it. The second thing is national finance, which has got to be at a state level. And then you've got the charging, which is very key. And then you've actually got the battery management. So that is already critical to the UK, but it's only 20% of the total picture. And so should we be focusing on that 20%, or we should open up our horizon? The basis of everything we're doing today is silicon, silicon, silicon. And the next generation of 20%, because of wide bandwidth and energy management, for the battery power, which we will excel in, yes, we can concentrate on that, but we shouldn't put all of our eggs in one basket. We should be looking at, because without the semiconductor and all the other integrated circuits, the opticals, the sensors, the drivers, DDAs, battery management, right, this still won't work. So we've got to be looking at the big picture rather than just the narrow picture. And we've got to be looking at what we can offer as a nation, the whole of the UK, not segments of the UK. how can we stitch this all together and make it work more effectively?
I'd agree with that. So you've got at least 15 fabs in different technologies in the UK, and the supply chain above it into communications, into power management, and into analog. And you need targeted investment in each of those areas.
Yeah.
It all exists, so it doesn't need massive investment, but it needs just investment and help to sort of grow in the particular areas. Because there's a misconception that one semiconductor chip's just like another, and it's always a race to the bottom in terms of smaller dimensions.
Sorry.
But actually, a lot of the supply chains are going back the way to higher dimensions, but at greater IP associated with it, and that's what the UK is very good at. So you've got, so people won't realise that you've got fabs in places like Oldham, in Bedford, in Greenock, in Stockport, in Newport, Londonderry, right across the UK, where you've got great capability in different parts of electronics. So it's not just one, and it supports the main drivers of CCAV and power management. So there's a real opportunity to have a we talk about regional focus, but there's sort of several regions, northeast as well, that can do that. So it's a very broad, one of the few industries where there really is a sort of spread, broad UK capability in different areas, and that should really be kept.
And I think basically the thing that our challenge, certainly with the NMI and together with Techworks, is really how can we get the message across the government. It is not spending billions, it's actually promoting the existing things. If you go to a stop, it's going to take years. But if you actually turn around, so you're going to invest in already existing companies that have got the IP, they've got the capability, it may be a scaling size, which is relatively small, to get the throughput and also to do maybe some of the shrink, then that is a relatively fast time to market, and it doesn't involve 2 to 3 years. So I think that's what we'll look at.
Yeah, and the other thing to remember is that these technologies are underpinning, so it's not just automotive. These can apply into exploitation into other sectors. So for example, if you look at the UK packaging capability, semiconductor packaging capability, you've got 4 or 5 sort of medium-sized companies in the UK that can work as part of the automotive CCAV and power electronics supply chain, but equally they can exploit markets in space and rail, where they are excelling. So when you're developing the automotive supply chain capability, there's 2 things. You can actually pull in capability and learnings from other sectors, or you can gear up companies that can also exploit supply chain opportunities in multiple sectors as well. So there's a real opportunity.
Yeah, I think just topping up that one, I think to the general public, the word semiconductor is a little bit ambiguous. But if you actually look at the application of the semiconductor, it goes in everything from your domestic toothbrush to your television, to your recorder, to your telephone, and then it goes into your track and trace. It goes into MRI scanners. It goes to every single piece of our day life. And it's the same, right? If we talk about semiconductors, people say, semiconductors. It's the ambiguity that actually diffuses or confuses people. I think we're going to narrow it down into sectors. The power semiconductor is critical. It's critical to the auto, to the drive management. It's critical to the solar power. It's driving the electronic revolution. And then it's put to our everyday life. And so the thing is, don't say, it's too expensive to go into it, or we can't enter it, or we have a defeatist attitude. We should be saying, yes, we've always excelled in this area. We can do it, we can bring it back. We can do it effectively, we've got the skill sets, we can do it effectively. Let's launch it, but we do need help. Yeah. And I think that is where the government can play an important part. If you look at Joe Biden is actually 250 billion, right, for this next 2 years into the tech sector. 52 billion actually goes into the semi-sector. If you look at that, you've got TSMC going to relocate in the United States. And so now there's actually the semiconductor is becoming a political gambit on a big stage. And anybody who doesn't participate are going to be left behind. And we can't afford to be left behind. Yeah. Absolutely. I think a lot of I deal with most of the customers in the UK and maybe across the world. And if you actually look at it, if you look at the German market, right, it's very homogeneous and it's actually all pulled together. Whether it is actually driving the electronic revolution, it's actually solar, very knitted together, but a significant, attention given to it by the German government. Same in France. If you look at China heavily, there's a big technology war going on between China and the United States. At the moment, China will say they will be, by 2050, they will be dominant in the semiconductor sector. to do that, it's not just the silicon, it is the equipment technology behind it. How is it done? Lithography processes. How can we stop that from happening between the two big races between China and the United States? What part do we play in Europe? If you look at the collaboration with our European partners, you've got people like ASML, the world leader, biggest revenues in the world, right? It's a European company. If you look at the design technology you've got here, through ARM and some of the rest of the capability, leading edge, you've got nations like China, Taiwan, America, all investing in here, small scale, and what they're doing is they're extracting all that information. We've really got to stop it, but we've got no protectionism. Joe Biden has actually turned around and said he will stop it, and he will invest it. So what attention has the government given to it? I think it's just been an easy income revenue stream, and we've concentrated too much on what we call the financial sector, and not on the manufacturing. And now, from the automobile industry, from the energy side, it's taken over. But the core of it all is the semiconductor. And if we lose that core of it all, then we could end up become second place and all the rest, or even third place. So we've got to concentrate on our own IP here in the UK.
Yeah, there is definitely the UK is actually good at collaboration already, and so the nature of electronic systems is a disaggregated supply chain. So in the UK, you hear all the arguments, you need lots more bigger companies. I'm not necessarily agree with that, because the nature of UK innovation is it's quite a flexible industrial base. But what you need to then do is those companies be able to work very closely with each other, so that if you're looking at, say, the co-design of a solution or a system, you've got the companies be able to collaborate to sort of develop that. And that gives you a sort of flexibility and leanness, which actually makes the UK very competitive globally, and particularly in the sort of niche electronics systems that we're actually talking about. So I think the UK is in a very good place to build growth through collaboration in electronic subsystems.
I think on that, just something to top that one up, it's all about speed to market, and speed to market is investment. And I think individual companies in the UK, small companies as they are, they do significant investment, but not the scale that people are doing in the United States or in Europe. And I think the government has really got to have a wake-up call.